A very good evening to everyone. This is Dr. T. Venkatramana. It is my pleasure to welcome you all to session 7 of ATAL Online FTP on Advanced Materials and their role in Industry 4.0. Today, we have the honor of from Dr. Chandan Srivastava, a renowned expert in data science and AI, currently serving as lead data scientist at Microsoft. With his extensive experience in AI, ML, and cutting edge technologies, Dr. Srivastava will provide valuable insights into how advanced materials are shaping the future of Industry 4.0. Let us extend a warm welcome to him and look forward an enlightening session. Welcome you, sir, and this floor is yours.
Good evening, Dr. Ramna. Thank you for the introduction. Please make me the presenter so that I should be able to share my screen.
Sure, sir.
Okay, thank you, sir. I'm able to share my screen, and please confirm if my screen is visible to everyone.
Yes, sir, it is visible.
Great, thank
You may
you.
proceed, sir.
Thank you. So as Dr. Ramna talked about, today's topic is advanced materials and their role in Industry 4.0. And as he also talked about introduction and added my expertise, we were looking at more how the Gen AI can help in the advanced material for enhancing or for increasing the productivity efficiency in the Industry 4.0. I'm less FYI, I'm less expertise in the material science, but certainly I'm expertise in the data science and others. And another thing, I am a bit not keeping well, so I might go a bit slow, but feel free to ask questions if anything. And how this session collaboration would, I am thinking of and need your support as well for all the participants. Just think of in your use case how the Gen AI, how the data science AI can be applied in your use cases. And please feel free to pitch in and answer questions to me. Agenda of today's session is generative AI in materials. We will look at the case studies. I also collected the 2 case studies, which is quite interesting and relate to the material science only. And within that, how the Gen AI is actually impacting, which is the first one is the use of Gen AI to design a new material. And the second one is automating self-learning the quality control using the computer vision technology. This is also very specific to the materials and one of the industry applications I'm going to talk about as part of this case study. Also, we'll touch upon the benefits of using the Gen AI in advanced materials and challenges and consideration. We have the few, I try to put it very generic questions as well, so that we will increase our interactivity. And as I said, please feel free to ask questions and based on your scenarios. As we knew and we have seen, these applications of advanced materials are in manufacturing, certainly healthcare, for advanced medical devices and development and implants those devices. In the energy sectors, the enhanced energy storage and for the conversion. Automotive, certainly for the lightweight vehicle and increasing the strength of those materials. Those kind of research are going on in very advanced fashion. There are more. I just limited here the 4 industry to take as examples how these Gen AI or the AI applications are helping materials industry to enhance their productivity. I have a question that prior to talk about the detailed agenda, and I would be very pleased if someone can chime in, which is, do you believe we can leverage Gen AI really in the development of the advanced material for Industry 4.0? Or if there is any example, any one of you can share, that would be great. I'm happy to have the more interactive session. Anyone from the participant? No one would like to touch upon, or no one is agreed on Gen AI can play an important role? Is that audible, sir? Dr. Ramna?
Yes, sir, you're audible, sir.
Okay,
Yes, sir, you are audible.
thank you. Thank you for the confirmation. Okay. So should I take yes of this silence and proceed further? Okay, then I am moving forward, and happy to take your views in between if you feel that no, this is not the thoughts, his correct thoughts to apply. Dr. Ramna, can you confirm that the faculties are from the material science only, or it's a diverse across the stream, engineering stream?
Across the stream we have, sir, including
Okay.
management.
Oh, nice to know, sir. Yeah.
Hello.
Yes, please.
Yes, sir. Good evening. So
Good evening.
there are, heterogeneous group, sir. It is completely both MBA and computer science background participant.
Oh, great to know, sir. Yeah. Okay, if I give my view, yes, I believe that the Gen AI can be applied in advanced material for Industry 4. And how? I will take a few examples. And since here the audience or the participants are mixed, please feel free to think of in your scenario, if it is not in the material science, the Gen AI application, that's okay. Please feel free to ask if you're working on any use case studies, and you see some challenge, or you wanted to apply something more innovative way. Please feel free to ask. I will try to give my best attempt on that. Okay, generative AI in advanced material. As part of this session, we will cover the introduction to Gen AI. I'm not going to cover introduction of Gen AI in this, because yesterday I covered introduction of Gen AI and also how that can be scaled. So we are going to cover on the very specific Gen AI in the material science, right? And as I said, think about your scenario. No matter if it is in the material science, if you think that in the other applications the Gen AI can help and you would like to bring some points, that would be great to have more interactive session. Gen AI role in material science, certainly we will look at, and how the Gen AI add in the discovery design of the new material. So we are going to look at one of the case study, that how the Gen AI can helping to design a new material, right, using the data sets we have. This is the one of the case study, as I said, the use of the Gen AI to predict material property and design new material. And here I'm going to talk about one of the accelerator, and that accelerator Git repo link is also mentioned here. So you can actually use this accelerator in your data sets. The model is given in Gen AI model is actually little slightly heavy model, so may not work in the CPU, or I don't know, it will not work in the standalone PC. That's required the cloud computing a bit. to work on. But all the detailings of this accelerator are present in this grid repo, and all the codes, samples data, understanding of this. Some videos is, and the video I'm going to also play as part of this presentation. Okay, Gen AI in material discovery. The example is the use of Gen AI to predict material property and
Sir,
design.
hello, sir.
And material.
Hello.
Yes.
Yes, sir. If you can enlighten us on generative AI also, because it's important and it is useful to other batch like the MBA faculty. So for them, you can enlighten on introduction part of generative AI as well.
Okay.
Because in academia, still we are in the process of utilization of AI, but industry already using generative AI. Okay. So if you can enlighten us, it will be really helpful to our participants as well.
Sure, sure. I thought of the participants are
Directly
the
we're going
same.
for case study. Maybe they may not get it. So can you please elaborate
Sure,
on
sure.
generative AI?
Yeah.
Thank you.
I was thinking participants are the same. That is why I have not included as part of this
This
session.
FDP we are conducting collaboration with MBA as well and the computer science departments.
Sure,
So
sure.
it
Give
is
me a moment.
international by itself, no? Yeah.
Sure. Give me a moment. I unshare my screen to open up
Yeah.
the yesterday PPT that I have, session PPT I created.
Thank you.
No worries. I did share my screen. Please come if it is visible.
It's visible, sir.
Yes, sir. It is visible.
Thank you for the confirmation. Okay. So let me start from the beginning, and we all knew, and specifically the computer science background people and fundamental of computer science background people might knew about it. Artificial intelligence, I mean the innovative artificial intelligence started from the Turing test in the 1956, where the experiment have been proceed to replace or to respond the human voice from one end to another end. Moving forward, there were several algorithms came into the machine learning paradigm. We worked on the supervised, unsupervised, semi-supervised algorithm, and in the area of the data mining, pattern recognition. These algorithms were extended to natural language processing classifications, as well as the computer vision to do the simple classification, object detection, and the annotation in this paradigm around 1997. Further, we have the deep learning in 2000 era, where these are the deep optimization algorithm using the neural network, and recurrent algorithms were helping a lot in terms of giving the faster decision or optimized decision using the large computation. Further, in the last 3 years, we are able to see that the generative AI started to play a crucial role, where the complex model as part of a single model is running behind the scene. And these models, you can think of the deep neural network or the deep learning neural network models are running behind the scene, and they are giving the lot of contextual answer to the end user. Primarily, Gen AI is initially started to work on the text data, right? And slowly it's enhanced to the image, videos. Now we are able to see that, the kind of the vision models, right? So it is not limited. And as part of this, one of the case study, we see that this is also helping in terms of the designing the new material as well, which is the theme of today's session. Right? And how this is happening, I will try to touch upon a little bit deeper in terms of the technology. So that the computer science department and the material science department core industry can work together and try to build the kind of the good solution. That's my objective of this session, to try to touch upon that. And certainly I will be also available to have some collaboration in terms of the guidance as yesterday. Earlier, we were looking at the traditional AI where the machine learning model, AI model, natural language based the classification models we were using so far, right? And that could be for the one persona or probably limited to the 10 or 50 persona. We were actually building that solution. But where are we now? All the industry, as I have taken the few example of energy, manufacturing, right, automotive, healthcare, they would like to scale their solution to the multiple user and to the multiple applications, right? So that the single model can talk to the multiple application. When I said talk, is actually provide the response to the multiple applications which end user is using. For example, patients, right? The patients are using the mobile app and getting the prescriptions, many details over the mobile itself, how that can be possible, right? With the simple UI application. But if there is some summary, for example, if I want to have the 6 month of my prescription history in a very crisp summary way very quickly, how I can get it? The GenAI is the solution which can provide. It will summarize your complete demographic information, your 6 month of prescription given by the doctor. Also, all the labs and procedure have been applied to the patient, can summarize all together and give the very summarized answer. There are many uses. I have just taken the one of the example. So that is why the GenAI is playing very critical role in this case, and for Industry 4.0, and everyone looking towards in terms of the scale using the GenAI solutions. And you can't believe, looking at my example, I mean, what I'm seeing the current industry trend is that they don't want to focus on the classical machine learning. However, their problem can be solved by the classical machine learning, and the problem is actually the classical machine learning problem, or the natural language processing problem. They would like to have the GenAI theme in their industry so that they can think big. So sometimes it is our duty also to make them aware. Yes, the simple and the lightweight model can help and solve your problem. But whenever you are going and talking about the scale, VU, and some complex problem to be in place, that certainly the GenAI can help you. I also have talked about it here, the kind of the generic architecture, or sorry, infrastructure, I would say that, where how this GenAI is actually currently working. We will start from the bottom layer where the AI infrastructure is can be in place. And to make the scale, we need the cloud computing. I am from Microsoft, that's why I'm using Azure, but it's not mean that you need to use Azure. It can be AWS, it can be Google, it can be other cloud if you wanted to use that. But the fundamental to go to the scale for any model, AI models, we need the platform. That platform can be leveraged by the cloud computing. And on top of that, certainly we need the data platform, right? Data platform can be SQL, MySQL, Cosmos DB, for the unstructured data, structured data, MySQL. So these all can be in place, or simple storage, right? And on top of that, we certainly need an editor where we can write the algorithms. That can be any Jupyter Notebook, Python editor, so that we can write those notebook. And once we write the notebook, we can bind that on the models. Once we train, test, we should be able to bind that model and deploy in an infrastructure which is at our bottom line, right? So that it can be leveraged as at scale. On top of to write these algorithms, we certainly need some services. For example, if we wanted to, when I say the services, you can think of other way like the packages, right? If it is online packages and very specific use that you can call it out and use it. But if the need of some sort of the computer vision algorithm that you need cognitive search, you need document intelligence to pass the text from the unstructured document. If you have the video data or the image data, you need the video indexer to index and bring out the insights related to the, for example, objects, right? So these all services can be the another layer which you can call. And as I'm going to repeat again, not necessarily from the Azure, can be the open source, for example, from the Hugging Face. We can do that, right? Speech to text, when we are working on the multi-language problem, we can actually leverage those services or the packages that is available at the open source. Okay, the first one, yes, Mr. Kanan, I'm using the same slide, and because the ask is that some of the participants are from the different background, that's why I am using for the introduction this one. Hope this is okay. And please bear with me. The idea was not to use this, used to the new presentation and dedicated to the theme of this session. The application certainly we can use for the end user is the Power BI for the end user to look at the dashboard, Power Automate to design the complete end-to-end application. We have seen one of the demo as well yesterday, where the end-to-end application works. Power Automate to operationalize at the application level the end-to-end flow, right? And design the Power Virtual Agent as well. This is also at the application level. As I said here, you can look at in the upper right corner, open source eco stack. Certainly, you can use any eco stack from the open source to use that. Now, to scale this, I also touch upon that what could be the framework can help, right? Because see, if we are on very standalone classical machine learning model, that doesn't work at all, right? Some research quickly you can do that, but that's like the hypothesis that you are doing it. To have the solution in place, we certainly need one framework where you can deploy end-to-end, where you can work on the end-to-end application, right? And that is where the different computer science stream works together. For example, the data engineers related to the applications, engineers related to the data, engineers related to the data science experts or the AI engineers, right? They all can work together and design a complete application using the Copilot stack. They can build those small copilots together with the help of the open source framework is available over the gate. So the AI infrastructure, I already talked about it. Here is the foundation model that we can put it here, pre-trained model, fine-tuned model, the custom fine-tuned model, and also the own model, the open source one that also we can put it in that. The orchestration used as a middle layer, which can actually help for write the different prompt and also write the different instruction, write the different more contextual, provide a more contextual over the data sets to my applications, which can actually help us to get the better response out of my model. And that can be seen as part of this Copilot front end, which is the plugins or the UX can be designed. Okay, generative AI. What do you think? Is the generative AI can be wrong? In my view, yes, generative AI can be wrong. And why? We have seen that the hallucination is one of the examples. Whenever we are using it, there is a possibility of the hallucination coming out. Then what are the kind of the preventions we are taking it, right? So these also we need to think of if the hallucinations come, how we are doing the validation, where is the human to validate that, right? The experts, and how the feedback loops are incorporating so that once my model is retrained, it should not bring those hallucinations popping up. Right? The filters are not yet effective sometimes with respect to the domain, but now as we are looking at the every month or every few months, there are the new feature release, which is actually enhancing the capabilities of the AI models. The system biasness, there could be the possibility of the biasness to understand that possibility of biasness in the data while training the model. We also touch upon the responsible AI, how we can touch upon how we can actually make sure that my data is unfair. And when I'm doing the model training, it's also not biased. So because the decision is going to depends on those ethical aspects, right? The individual company norms, the values are not reflect. So this is more domain specific work, and how this ChatGPT or how this AI models can work. It can actually help us in terms of giving the response in a batch process as well. So the Q&A can be answered in a batch process and get the response very quickly for the many end users. We cannot claim here any intellectual properties or IP. This is some legal aspects which industry people are looking, because these models are actually foundation models and the more grounded by the, for example, the OpenAI. I just touch upon that the ethical aspects while working on the AI or ML solutions. So whenever we are designing any solution, we need to be accountable what we are building it, right? And it should be fit for the purpose. When I said that, it should be good for the human. Transparency, everything should be transparent while building and designing the AI solutions, because these aspects are very critical nowadays. Fairness, our data, our models should be unbiased and unfair when we are building on anything. We should not add also any assumption as part of the fairness principles, and we should be very careful if we are assuming something in terms of, for example, for the increasing the minority class in our data set. The liability and the safety, we should have all the failure remediation plan, and the human validation should be in place. Privacy and security is related to the data privacy and also the network security. Both are combined in this case. The inclusiveness, it should be inclusive. For example, the gender biasness should not be there, right? And if anyone is challenged with some physical activities, our model should not be biased for them, right? I'm now again switching back to the original theme of the session, and please feel free to ask any question meanwhile. Yeah. Please let me know so far any questions, any doubts, or any thoughts to bring to here. Okay. Now we are coming back to the original topic, and we will look at here as part of this first case study using the Gen AI, how we can predict the material properties and design the new materials, right? I have taken the very simple examples, and there is one video as well to get the feel of, and this video of the same team which has built this accelerator. And of course, this can be used for the faster development cycle and the innovative solutions, and every industry 4.2 are looking towards the same. The accelerator name is MatterGen, and why this is it is in the advanced material number 1, used for the advanced materials, and behind the scene the Gen AI models are working. Right. So MatterGen is a generative AI tool designed to create the novel material with a specific property. So we will see that how that's can possible with simple examples in the video demo. It leverages the enhanced AI techniques to streamline the material discovery process. And example is the discovery of the lithium cobalt oxide for the lithium iron batteries, how that can be built on. We can see it here, a very simple example of the MatterGen, where the Gen AI is actually working in the background, which is a new paradigm of the material design with generative AI. So far, we were using some tool, and there is a comparison as well slightly about with MatterGen versus the other tool of doing some design process. And in that case, this MatchGen is very efficient. Why? Because behind the scene are the very specialized models those are embedded with those specific the material science, and they are working. And similar like yesterday, I touched upon the biomedical specific model like the BioBot. The similar like here, these models are specialized and embedded GenAI models with the material science specific problem. So we can think of here the example is that you need to think of the design. What could be my material, new material designed and the color? This is very simple example. This MatchGen will increase will screen based on your input given. This is similar like you are asking the question to the GenAI, and GenAI is actually looking at with the pre-trained embedding and giving the response. Very simple example. Similar like you need to just give the design, think of the which color of the particular property it could be, and that can actually try to screen in the pre-trained model and give the response for the MatchGen, and you can look at here. Right. So this is very simple example. There's a size plus the color, and it will give the similar kind of the product which what we are expecting to design. Directly generates the novel material based on the design requirements, reduce the need of the extensive material trial and error. What we usually do, initially we started with the manual process, right? And we will see that what are the challenges while the manual process and some other tools were helping, and what is missing out, and which is actually capturing by this MatchGen. Enable both properties and guided material design. Right, this help because it's very specialized and fine-tuned in that way. Here is the example of the traditional steps that so far using with some of the tools. Whenever the random materials are coming to us, coming to the industry research group, what they are doing it, they are thinking of some process using some properties of the materials, and they were limited in terms of the material, and using some of the tool to design some stable material. And the validation process of these stable materials are very, very complex to do that. Right? Always there will be some defect. They don't know how to achieve the quality of those materials. Okay, where the MatchGen can help. MatchGen, you need to tell that what is it. This is related to the chemistry, symmetry, and the property. If you have those inputs, please give those inputs. It will actually design the solution based on the input is given. For example, lithium cobalt, we have discussed one of the example, right? And it will actually design those architectures and the bonds between the structural properties and giving you the answers, right? And it will combine those answers as a final design outcome. This is very efficient in terms of the screen the millions of candidates quickly and accurately because it's already specialized with the similar kind of properties. So it has all the information. Similar like I talked about yesterday, the BioBot kind of model. They are actually specialized in the healthcare related information. They knew if the symptoms of the patient is having, so what could be the possible disease or what could be the prescribed drugs. The same example applies here. The design material for the high conductivity, the lithium-ion battery can be designed and to test it out. MatchGen performance here with respect to the other tools that also have been tested out with the research team, and it's identified those are quite stable, novel, and the unique structure when they have tested out. So to go through with this, the Git repo and try to explore it, if able to configure, is actually based on the Linux system. We can look at here the label data. This is the outperforming screening given by the MatchGen is the blue line with respect to some other screening process can be applied in this case. Right. I will go a little bit quickly, and this is very important for the handling the composition disorder. And why it is? Because it is very difficult earlier and so far, and by many of the tools to handle when the random structure or the random interaction between the bonds are in place, because they don't know where the one bond has to interact with the others. So how this composition disorder need to treat with? If the model is not trained, either you need to write the very specific Python code or any language which you are working on, call some packages, write the extensive code. But now these problems are solved by this specialized model. And these models are continuously improvement in the AI model. So it's keep enhancing, expanding the applications to the new fields. That's also the possibility, right? The MathGen is the transforming material science with the generative AI, and it's offered a faster and a more efficient way to disorder new materials. The question can come from your side. Okay, we also talk about just before the Gen AI model, right? We are also talking about the ethical aspect, and we are using here blindly our complex model to design a new material. Then what's this? How the validation is going to happen? Where is the human? So the ethical principle is that as soon as you design a new material, you have to send to that material for the lab test for the validation. Unless it should not go out for any production line. That's a thumb rule to be applied in that case. And here is the MathGen video. Please let me know if you are not able to see the voice. Sorry, not listen the voice. Is the voice is audible to everyone? Can anyone confirm?
Yes, sir,
Yes,
your
sir.
voice.
Okay, thank you. And just one more for intellectuality, I am going to ask few simple questions. So please listen carefully and giving the hint that these questions, simple question is going to relate with the Gen AI or AI. Is this video is not audible? I just got
No, sir.
confirmation.
No, sir.
Okay, but just before I got confirmation, yes.
We are able
Okay.
to see it, but not audible.
Okay. Actually, I asked, let me check. Sorry. Give me a moment, please. Not sure what I need to. If I share the link, is it okay? Meanwhile, for the interest of the time, instead of struggling with the properties, I'm going to share the link. Where is the chat? I just share the link and I'm giving a couple of minutes. Just please go through with that because the next I have very basic question to ask. Has everyone received? This is a YouTube video only. Please let me know once you are done with your watch. We can wait for a couple of minutes.
Hello everyone, my name is Tian and I'm from Microsoft Research AI for Science. I'm excited to be here to share with you MetaGen, our latest model that brings
Is now audible?
Yes, sir.
Oh, great.
generative AI to materials design. Materials design is the cornerstone of modern technology. Many of the challenges our society facing today are bottlenecked by finding a good material. For example, if we can find a novel material that conducts lithium very well, it will be a key component for our next generation battery technology. The same applies to many other domains, like finding a novel material for solar cells, carbon capture, and quantum computers. Traditionally, materials design is conducted by search-based methods. We search through a list of candidates and gradually filter on them using a list of design criteria for the application. Like for batteries, we need the materials to contain lithium and to be stable, to have high lithium-ion conductivity. And each filtering step can be conducted using simulation-based methods or AI emulators. At the end, we get 5 to 10 candidates that were stable, that were sent into the lab for experimental synthesis. In MetaGen, we hope to rethink this process with generative AI. We aim to directly generate materials given the design requirements for the target application, bypassing the process of searching through candidates. You can think of it as using text-to-image generative models like DALL-E to generate images given a prompt, rather than needing to search through the entire internet for images via a search engine. Core of MetaGen is a diffusion model specifically designed for materials. A material can be represented by its unit cell, the smallest repeating unit of the infinite periodic structure. It has 3 components: atom types, atom positions, and periodic ladders. We designed the forward process to craft all 3 components towards a random structure, and then reverse this process to generate a novel material. Conceptually, it is similar to using images, but we build a lot of inductive bias, like equivariance of periodicity, because we operate in a sparse data regime as in most scientific domains. Given this diffusion architecture, we train the base model of MetaGen using the structure of all known stable materials. Once trained, we can generate novel stable materials by sampling from the base model unconditionally. To generate the material given desired conditions, we further fine-tune this base model by adding conditions to each layer of the network using a control net style parameter efficient fine-tuning approach. The condition can be anything, like a specific chemistry, symmetry, or any target property. Once fine-tuned, the model can directly generate materials given desired conditions. Since we use fine-tuning, we only need a small label dataset to generate the materials given the corresponding condition, which is actually very useful for the users because it's usually computationally expensive to generate a property label dataset for materials. Here is an example of how MetaGen generates novel materials in the strontium vanadium oxygen chemical system. It generates candidates with lower energy than two other competing methods, random structure search and substitution. The resulting structure looks very reasonable and is proven to be stable using computational methods. MetaGen also generates materials given desired magnetic, electronic, and mechanical properties. The most impressive result here is that we can shift the distribution of generated material towards extreme values compared with training property. This is very significant because most of the material design problem involves finding materials with extreme properties, like finding super hard materials, magnets with high magnetism, which is difficult to do with traditional search-based methods and is the key advantage of generative models. Our major next step is to bring these generative AI design materials into the real life, making real-world impact in a variety of domains like battery design, solar cell design, and carbon capture. One limitation is that we only have validated these AI generative materials using computation. We're working with experimental partner to synthesize them in the wet lab. It is a non-trivial process, but we'll keep improving our model in feedbacks from the experimentalists. And we're looking forward into a future where generative AI design materials can make real-world impact in a broad range of domains. Here's a link to our paper.
So there is a link of the paper as well where this MatGen is published, and also the Git repo which I'm going to share as part of this PPT later on. Okay, those have watched carefully. Very fundamental question: which Gen AI model is running behind the MatGen? We talk about few things. Can anyone volunteer to talk about what is related to the AI model, Gen AI? If not, certainly I capture that. Can anyone volunteer? Not a single word. Anyone watch it or feel it, which is related to the AI? No worries. Yes, traditional search. Very perfect, sir. So this is a Gen AI model, which is actually coping up as Sir talked about moving up from the traditional search, because so far earlier model and the early tools or the approaches were to have the generic search on the corpus, which is nothing but our data sets, right? So what have been discussed in that video is related to the AI is generative AI have been used as a backend. Which model is specifically used? Point to be noted as DALI, which is very much a specific model in terms of the design, and it's help actually image to text, right? And even you can give the text and you will get some response. So DALI is also used for the image annotation, doing the design, and it's helped a lot. Now, just
Hello.
for the awareness, sorry.
Sir, good evening, sir.
Yes, please.
Hello.
Yes, go ahead, please.
Hello. Am I audible, sir?
Is that
Hello.
yes?
Sir, you are audible. You please proceed.
Yeah. So See, now you discussed about generative AI, sir. Then now people are talking about experience AI, right?
Mm-hmm.
Hello.
Yes, I'm hearing, sir. Go ahead, sir. Is I audible?
Yes, sir, you're audible.
Yeah. So
Okay.
can you explain us like the differences between the generative AI and experience AI, and how the experience AI may lead the material stuff? So
Sir, can we slightly distinguish right now the experience AI right now? And can I take it at the later? Is it okay? Is that okay, sir?
hello, sir. Hello.
Yeah. Yeah, I'm saying it. Can I take it this question later? Because this is related to the kind of the comparison between experience AI and generative AI.
Okay.
Is that fine?
Yeah, yeah.
Have you heard that the experience AI as well as part of the demo?
Hello.
Yes, I'm asking a question to you. Have you heard experience AI in as part of the demo?
No, 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 sir. I think you didn't discuss about it.
Yes. Okay, so I will touch upon, sir. Certainly, I am taking the note of your questions and I will touch upon because slightly different but related to the Gen AI. The objective are remains the same in terms of the AI capability of experience AI.
Okay.
Yeah, so I will touch upon that.
Okay. Okay, sir. Thank you.
So what I was with respect to the specific topic which you are talking about is the Gen AI was a part of this model certainly, and the DALI is used for the design, and this models can help in terms of the image to text, text to image, to make a more interactive solution. But this is very heavy and costly. This requires, I think, the GPU. It may not work in the simple CPU standalone machine, right? It's also talk about the Pi3 because there are the search, there are some intelligence analyzing the data. So the Pi3, the small language model, is also work. In the video, they also talk about the fine-tuned diffusion model based on the some samples data. So there are the base model, and on top of the base model, there are the fine-tuning applied. The fine-tuning applied on top of that model, and so that that model can become the very much specific the purpose of what scientists want. So the purpose is for have the to have the new design in place based on the several learning. Okay, we will look at that how that fine tuning can be possible, right? And as rightly observed by one of the participants, is instead the search based, right? So instead of the search, it's going to use a complex model for the design, for interacting the or the particles property from one particle to other particles, and to make the new particle based on the ask, right? So these all are the things actually kind of the key area in terms of the exploration. Please do not think that this is slightly different, the fundamental of machine learning. You can think of like we have a data can be formed in terms of numeric, categorical, image, video, right? And some text format. These data you are using to develop a model. When you are developing a model for the specific purpose, you need to fine tune. When I said the fine tune, you need to retrain all data to meet your objective. Look at that perspective and go. And this topic is just, I would like to highlight this is very interesting for me because my PhD, one of the topic was based on the biodegradation, where the two chemical properties are interacting each other and forming a new chemicals. So that's why this was very interesting topic for me. And I am from pure computer science background. When I started my work, the field called the chemoinformatics. Everyone might heard about this field name. So in that case, we were interacting with the chemistry, the lab people, and understanding the chemical properties, the structure property, and build the machine learning or the AI solution. At that time, the more than one and a half decade, we were using the big models, actually the writing the algorithms to have our objective in place. But nowadays, we have a complex model. The several packages are in place to do this tedious task. And instead of working on this tedious task, actually to focus on the objective which we wanted to achieve. That's the beauty of this. That is why you can actually think of that in terms of you can apply data science, AI, Gen AI in any topic. So that's one of the beauty actually is just we need to have the courage of to understand the new models, new area. Okay, the question is related to the fine tuning. What it does mean by the fine tune model? I actually already touched upon. Can anyone answer this? Can anyone touch upon the what is the meaning of the fine tuning? No one? Okay, the fine tuning I touch upon with a very simple example is that like we are building our models, right? And we require some training to find is similar like the fine tuning of a model is the approach of doing the fine tuning in the Gen AI model is slightly different than the traditional the machine learning or the AI or the NLP models we have seen so far, right? So we will touch upon that how that look like, and this is more specific to the computer science, and I would like if the computer science experts here can collaborate with the other departments and apply their computer science skill to others. Right, sir? And we can think of to start with whenever we need to do some kind of the retraining or training to refine our model. What should be our very first question should come to our mind? What model should work in my specific use? I mean, it should be clear that very first thing what I wanted to achieve. And to achieve that, which model is more appropriate? So we need to look at the different varieties of the model and analyze that theoretically first, which one is more applicable. And I will touch upon that hypothesis approach as well. What is the data I'm going to use and the data complexities involved? What should be my validation or the evaluation criteria, including the benchmark, so that I should be double confident. And we can see that in the MedGen, although this Gen AI giving the solution, but the final design product they are sending to the laboratory to get validated. This is very much important, and this is actually the tied up one of the example of the ethical AI. It should not release into the production without any confirmation by the human. So do I require the fine tuning or the retraining? If yes, at what level we required that? Okay. If we look at the one of the example of the small language model, which is actually also using as part of the MedGen. So whenever I'm doing this kind of analysis, I always look at that the different models which is available in the families of the model. Because for example, my objective is to serve to get the response with the small model of to get the Q&A, got the questions and provide the response to the end user, or summarize the chemical structure properties are given as an input to in my data, right? So for this, which one will work? There are different paradigms you can look at, and these are the standard evaluation metrics, the reasoning code generation, factual knowledge, language understanding, maths, if that involve, the popular agreement benchmarking. Why the math? Because now we are also asking our Gen AI models to write the code as we were discussing yesterday. Okay, is this quite enough for you? Maybe no. We always need to do some quick hypothesis that to validate yes, which specific model is really work. Take the sample of your data, take some properties, right, some features, prepare some samples data, put it into the model and get it validated that yes, this works for you, right? What is the final objective you wanted to use? You want to deploy this as a complete application. So of course, need to think of all the infrastructure and all. Does as I touched upon just before, is the model is if we wanted to do the retraining, is that retraining is possible or not? If yes, what kind of retraining can be possible? What should be my performance benchmark? So if you do not have any benchmark, usually what we do that we take the samples data, we test it out and take those benchmark larger iteration, or take the benchmark of the other research pupil which is available online. Approach. So whenever we are going, we are looking the very first point, which model can be applicable for us. So there are big families available over the cloud, over the edge. We need to look at what is our objective. Is this related to the content generation, multi-bound modality, where we wanted to have the image to text, text to image, video to text, or we wanted to combine the several properties of our materials and have that knowledge in place, right? Or we wanted to have some customization, this rack-based solution we have touched upon yesterday, but this all tie back to the fine tuning. Okay, these are the Azure and as well as Google, as well as open source technology stack where you can use it. And the open source one is the Hugging Face, the model family, where you can search the respective model. So stable diffusion can also serve the same purpose, which is the DALI I talk about it. And that diffusion, you can find it in the Hugging Face for your image analysis. The similar kind of things is just touch upon here. Yeah, we always need to look at what kind of the model we wanted to build based on our objective, and we need to look at what is the availability of those models. Do we need to look at Azure or we need to look at the open source, right? And if we build that model, where that model get the compute or CPU or how I can deploy it at the end of the day. Also, the consideration of selecting the foundation model, because this is very critical, as I said just before. Selecting the models from the large family we have, is this give the AI quality, and that is why test on some samples that are always work. Is this give us the opportunity to the customizable, because many models are the pre-trained model. Is there the fine-tune features is available or not? What are the features involved as part of this model that also need to consider it? The price, cost, and latency is also another aspect, because GPU cost or the CPU cost is also matter when we are doing the large operations. In this case, the objective, for example, we want to do these things on the cloud or in our standalone PC or the mobile. We always need to look at every model family in the different aspects, how that can be work on with a low cost, low compute, standalone in my PC itself. What is of course, based on the objective, is this can to me very quickly based on the data set I have it, or based on my final objective, what I wanted to, because if we wanted to apply this trained model on the millions of data, then we have to really think of the latency. This is the important aspect of the industries. So whatever I'm mentioning here, the kind of the benefits are actually captured from the varieties of the industry. Manufacturing, energy, retail, FMCG, these all industries are focused on these aspects in terms of the cost, efficiency, and the easy to deploy and easy to use. And is that help actually for their business too? Because they have to invest the cost, right? Is that cost proportionally are better than to apply the cost on the development side. If we look at the fine tuning, there are the fine tuning, two types of fine tuning. As I said, the question is this the fine tuning is required? Number one, test it out on the pre-test. If that doesn't work, look at the out of box fine tuning is available as part of the framework, which is available in the Azure as well as in the Hugging Face. And I am taking the example of the AI Studio, which is in the Azure. There is the availability of the custom fine tuning that you can do it on your PC as well. So look at here is one of the example when I was selecting one of the model here, I have looked at here if the fine tuning feature is available as part of this open source model. What are the properties of these models? Is this a serverless API can be used in my standalone device or not?
No? Ruby?
Yes.
Would you?
Sir, can you mute?
I request
So,
all the participants, please mute yourself.
Thank you, sir. The custom fine-tuning techniques can be available. There are different types of custom fine-tuning. I'm just touch upon the two, supervised and unsupervised, in terms of the GenAI model, which is the SFT, the supervised fine-tuning, and this fine-tuning is actually required the label data, which is the same as talked about in the MathGen. And the second one is the RLHF. This is actually the feedback loop. So once this model is actually giving some output, that relevant output is test and validate and feedback to the model and get the fine tunes. This is very critical, and this area is very new, which we are working on and to getting down. And what I'm sharing here right now. Here are some standards approach to do the partial fine tuning, because sometimes partial fine tuning can work, but in the MathGen, it is required the custom fine tuning, and here are the approach of the custom fine tuning to do one by one, so that you have the more robust, reliable, scalable model to be in place, so that can serve the multiple purposes, and that's what they have done it as part of the MathGen. As I said, as I talked about it, the fine tuning benchmark, of course, we need to have some accuracy, some benchmarks would be available, or create those benchmarks so that you will able to compare those, yes, you are doing better, because always precision, recall, false positive, false negative may not work, right? So the question can come here, I'm talking about one of the accelerator which is given by Microsoft, and this is MathGen. It might be difficult to deploy, right? It might be difficult to use. And that is why I touch upon how the custom way you can use that. So if you think of which plain vanilla mindset, as I said, and I'm keep repeating that, use some open source model for define the objective, what you want to do, have some samples data. The approach we also discuss, the key challenges whenever we are going, which model will work, data complexities, evaluation strategy, which is validation, how that can be fine-tuned or retrained for the specific purpose, and do that. So you may not require to use this accelerator. That's my overall objective, to give you after the MathGen, after giving the MathGen overview, this fine tuning, this can help you by itself and make you independent to do your modeling by yourself with the less cost, because sometimes you are doing it with your research purpose itself, right? So you can start your experiment with this open source data with the limited data sets. Open source is available, but these are the few standards things which always we need to think of to proceed further. Any questions so far? Because next is the case study 2. Please ask. I mean, this case study is less important. More important is that if you are working on some use case, or if you're working on some research scenario, and if you see some challenge, and I would be happy to discuss those. Don't worry about it, the theme of this session.
I request all the participants, can you please interact with our speaker? so that we can receive more inputs from sir. Please.
Okay, then I would consider no question. We have few minutes left. I will try to cover up the another case study, which is specific to the manufacturing industry and more focus on the manufacturing assembly line. So this is related to the quality control in the assembly line. And you imagine that specifically this box on the right side, upper one, S016, S012, starting from here. Imagine this is one of the steel industry, like similar like metal, but this is not the use case of Indian industry. It's abroad one. And they are melting the heavy steels actually and forming a big plate of those, and it's very heated. So what is the scenario when it is coming to the plate? They have in this assembly line, they have a big process to do that. I'm not going to talk about that process. I'm going to talk about the challenges and where the AI actually worked a lot. So what is happening there in the assembly line? This sheet of the steel was quite heated, right? And factory workers manually need to analyze the defect on this sheet. It might be scratch, it might bend, it might crack, right? There were a lot of defects that actually impact a lot their business, and it's very costly because once this complete product is actually processed through the assembly line, it is very difficult actually to redo that. A lot of raw materials are in place, and the other processing costs are in place, right? And also it was very hard to people to look at their eye and identify the defects in the sheet, right? So there are different categories in terms of the quality of the product, as we knew that. So if the higher quality, it will go to the higher industry for manufacturing the aeroplanes, right? The branded cars, for example, right? If it is lower industry or very lower product quality, it will go for forming the vessels, right? The steel vessels, for example, I'm just giving, right? So, or if the quality of this product is very poor, it will go to the government, right? So that's another, the waste of the cost is associated. So what they wanted to identify the defects over the sheet and increase the efficiency in terms of the identification. What we suggested to mount the camera, and with this camera try to analyze. How to analyze? Even the camera is in place, it can actually go quickly and pass actually this over the assembly line and may not able to identify all the defects. Okay, that is the place. So just think of computer science pupil. This camera is giving us the video, which is our data, right? For doing the object detection. And this is purely the object detection problem in the assembly line, where we are identifying using this video, the defect recognition and the defects classification. The kind of the defects are, there are the different categories and the classes. These defects are on the assembly line where, as I said, and identify those defects from the sheet and to analyze that. The different computer vision algorithms have been developed. It's also used the performance matrix with respect to the specific industry standard to look at the quality meet the quality matrix. right? So these are the different ways. I don't want to explore this, but I just wanted to give you the feel that computer science is an area which is now applicable across the industry. And Industry 4.0 is looking forward towards the same line. So we always need to think of that way, how we can leverage these opportunities of the different families of the model for our specific use and apply those things. Yeah, so building these solutions, we, as the part of the MatGen, we have the very low samples from the unlabeled data. Similar, like in this case, we use the Azure machine learning labeled algorithm. There is an open source labeled data algorithm is also available, which you can use to label the algorithm. And on top of that, the k-mean clustering used to make the segment of the similar kind of the labels to proceed further specific to this case, right? And this is nothing but the standard or the traditional process, input data, feature engineering that we are doing it, right? Identifying the feature important and the, of course, the model development and the validation of the data, and finally the output, right? It's just you need to think of in that way, is model is keep on the defects. My label data should be, the corpus should be enough and should not be biased as well when we are doing the labeling. That labeling should be validated by the expert or validated by the people manually first and then the automated way. The benefits of using the GenAI in advanced material is, of course, increasing the efficiency, innovation, and the cost reduction, which across the industries are looking forward, right? And they wanted to accelerate the research within the same area so that their business unit can get benefited. Of course, as per this theme, we also look at here the discovery of novel materials, how that can be, the unique property can be designed and apply and can be published as a research, as well as that can be benefited to the industry as well. So if we are able to do this kind of work, then of course the paper will go in the Nature or in the very reputed journal. Cost reduction, certainly, we have to think of that. The challenges and the consideration that always we need to think of. Do not think of standalone model development whenever we are doing it. Think of the combining the Gen AI with the existing material science workflow. You can remove the material science and apply this in any industry which you think of. Data quality always be important, and we always need to think of, otherwise our training and the validation and the output all go waste. Ethical consideration, as I given the example of, it has to be validated, and if that require the human validation, lab validation for the specific industry, that has to be in place. The future trend that we are looking forward here, the collaborative, the robots, the working alongside human in the material handling, the edge computing, deploy this solution into the edge, the 5G connectivities in terms of enhancing the communication for a smart manufacturing and such sustainability development of the eco-friendly material. I would like to conclude here with the summary that today what we have seen that is we have seen how the Gen AI, of course, we have looked at the introduction of Gen AI, of course, and how the scalable Gen AI can help the industry, which industry that can help. As per the theme of this session, we have looked at the accelerator MatGen, where the behind the scene the Gen AI models are working on. We also have seen that how the open source model or the approach of building the open source model can work on the any industry, not specific to material science. It's quite generalized. So we need to define our objective and take that forward. We also look at another case studies, which is in the manufacturing industry, specific to the computer vision case study, where we are analyzing using the vision algorithms to analyzing the defects, creating the different classifications of the defects, as well as I've missed to mention that it was giving the bounding box also of the defects available in the sheet. So that's give the very clear guidance how long is the defect, is what is the angle and the edges length is there, right, and why it is coming. So they can look at the root cause as well. Call to action, as I mentioned that, please explore the integration of advanced materials and Gen AI, not necessarily the advanced material, but since this is a theme of the session, I always emphasize the advanced material and in your projects, and happy to support and collaborate for future. Yeah, any questions? This is something what I plan to conclude.
Dear participants, if you have any queries, please interact with our session speaker. Or please post your queries through chat box.
Thank you, sir, for the feedback, Dr. Prakash. That really matters if there is any opportunity for me also to improve. Sir, if there is no question, we can conclude. I never expect this much of long session I would able to manage today, but I think the good vibes were coming and I'm able to do that.
Good evening, sir.
Yes, ma'am, please.
I don't know whether it is apt to ask it or not. Usually, unethical things are going on, and AI may be able to generate and help up our society. But even these models, whatever that they are regarding the validation part, when you are coming up, is there any way that these people can manipulate the things in order to run their or in order to meet overcome their counterparts in the industry?
Very valid question, ma'am, and that is why I touch upon very quickly today and yesterday slightly more in detail. The ethical principles always when we are building any solution. And nowadays, just to let you know, for the research purpose, I don't know if we have any the ethical things in place to submit. But in industry, if we are building any solution and if we are putting into the production, before moving the production, there is a review happening with the responsible AI framework. And we started, especially in Microsoft, and slowly that expanding to various industries, and they are also following. So, ma'am, it is kind of the best practice. And as a researcher and the scientist, it is our moral duty to follow those best practices, so that
Thank you,
there
sir.
should not be biasness, ma'am, in terms of building the model.
Yeah. Because mere competition, they may be surpassing their counterparts. No? So that is the reason we are worrying about.
Yes.
No doubt it is helpful
Yes.
to in many aspects. But coming to some
Yes.
areas, we cannot compensate that loss also, right?
Yes. Yes, ma'am. And that
On
is
research
why
side, we have plagiarism acts and all those things we have actually.
Yes. Let me
Thank you
quote the
very much.
example, ma'am. In 2019, in one of the company were caught up by creating the bias algorithms, which is filtering out the female candidate for the specific job profile. So they designed that algorithm, the AI system, in such a way that can filter out the female candidates for that particular job. And they caught out and they penalized like very hard in
Oh,
US.
okay.
So yes, ma'am. So these rules are becoming very hard, and that is why we are very much, alert in that. So whenever we are starting to think of any use case, we always need to think of ethical perspective, how ethical it is. And this is our moral duty of all of us together,
Yes.
as we are in this research area or industry together.
Thank you for your enlightening information, sir.
My pleasure, ma'am.
Thank you so much.
So one more question, if you permit me to. Because we are material science researchers, some of the products which we are going to research on depends upon the ambient conditions. So could it take like temperatures, pressures, and all those things?
Yes,
So how
certainly,
this
ma'am.
model can support us? Sir?
Ma'am, this is little experimental
Yeah, yeah.
answer. I can experimental that need to test it out and then only I can give it. So if
Yeah.
we have the specific scenario, but certainly, ma'am, there is a models and we have done the similar kind of case studies where we are using the temperature, ambient temperature as well to for analyzed by our model. So that's work. I mean, that's what I wanted to convey, but it's experimental strategy that need to define and do some experiment to analyze
The
that.
trial and error only.
Yes, yes, ma'am. Yes. And we need to look at the feasibility also, how much this is working, how much tuning is required. Is there any drive
Yes.
feature need to incorporate with, for example, the rest of the property may not be correlate with your temperature property, right? Temperature feature. So
Yes,
how
sir.
that can be actually, we need to drive that feature and to be the part of our model. So, I mean, this is the experimental method.
Okay. Thank you.
Sir, shall I proceed with conclude, sir?
Yes, I would be,
Yes.
I would be
A
fine.
big thank you to Dr. Chandan Srivastava, sir, for an enlightening session on advanced materials in Industry 4.0. Your insights have deepened our understanding of how AI and advanced materials are transforming industries. Today, we also explored the AI infrastructure needed to drive innovation, the importance of fine-tuning AI models, and selection and comparison of models like Pi3. Additionally, we discussed the role of open source models for generative AI, which are making AI more accessible and customizable for various applications with real examples, like manufacturing industry, just now sir covered. We truly appreciate your time and expertise. Thank you to all participants for your engagement. And I request to all the participants feedback link for the session we already shared through chat box. I request you all fill the form. Thank you once again for giving this great opportunity.
Thank you, sir, and thank you for all the participants. Your feedback will be very much valuable for me and also encourage me for my another session. If there is any opportunity, happy to do that. Thanks a
Thank you,
lot,
sir.
and have a
Thank
good
you, sir.
evening to everybody.
And I request all the participants, next session will be starts within 10 minutes. Thank you.
Good evening to all. Satyam sir, are you available?
Yes, I am.
Yeah. So we will begin in another 2 minutes, sir.
Sure. No
Yeah.
problem.
I have made you co-host. You can share if there is any file to share. You are the co-host now. So in
Okay.
another 2 minutes, we will begin the session, sir. Sangeeta?
Yes, ma'am.
Yeah, conduct the session. You just wait for 2 minutes and then start.
Okay, madam.
Yeah.